To begin, at the top of the code, I use two time intervals, T1 and T2. These are for measuring the 10 tau period and the tau divided by 50 period, respectively. Within my loop, I set the first state to equal not state, so every time it goes through the loop, it changes states. So the first iteration is going to be high. Within the secondary while loop, I can show that every single time it hits tau over 50, I reset that interval and I take a measurement. Within the monitor right here, you see the 10 kilo ohm resistor. This shows that every 10 tau or every 1 second, it switches. For the next, the 100 kilo ohm resistor, every 10 tau is every 10 seconds and will be shown with a speed of about 2.5 right here. For my processing code, as you can see, it's working as intended. The line segments are in a range of 550 minus 38, which is 512, divided by 5 because I want 5 segments. That's going to be around 102, which is what you can see in the division in the lines and also the text. For the text, I just set it to be minus 10 above the y-axis so that it's above the line and you can see it correctly. For my legend, I just copy-pasted the initial ellipse for what's shown on the actual graph and on the actual code, and then I adjusted it to make sure it's in line. The window flashes every time x is greater than 1200, and as you can see, both the 100 kilo ohm and the 10 kilo ohm is consistent with the RC simulation shape. For my MATLAB code, I copy-pasted the entire code so that I could get two plots at the same time. For the plots, I made the axis so that it was dependent on tau, as you can see, from a range of 0 to 4 to a range of 0 to 40. Both of these plots are consistent with the theoretical and experimental tau of 0.1 and 1 seconds, respectively, for 10 kilo ohms and 100 kilo ohms. For the voltage divider, I decided to use a 10 kilo ohm resistor because the datasheet says that at 25 degrees Celsius, the thermistor has a rough resistance of 10 kilo ohms, and voltage dividers have the greatest change when both resistors are equal. For the shape of the thermistor graph, I put it back into the MATLAB plot for the analysis, and you can see that the shape is consistent with step inputs for first order systems.